Alright, welcome back to the BCPC3 solution videos. In this video, we're going to be talking about Windows 10, which I think was probably, or what is it, the fifth easiest problem in the set. So definitely kind of a tricky problem, but still pretty doable, I'd say. So Windows 10 was about the interesting thing that Microsoft did in skipping Windows 9, which also happened with the iPhone 9. So if you remember, it went from iPhone 8 to the iPhone X, which was pretty much the iPhone 10. And then after that, they started doing numbers again, so back to iPhone 11. And it was kind of interesting, so I was looking at the reasons why they might have done that. One reason was because of Windows 95 and 98. So if you started matching the operating system with like the first prefix of a substring of the name, then you might get weird things happening. But that's not really that interesting of an idea. Like it's kind of weird. Instead of like making people fix their code, you just change the name of your product is an interesting design choice. So the more likely thing that probably happened was that saying your product is like version 9, it's like almost a perfect version 10, but not quite. So it's like kind of an interesting product, but maybe you should just wait for the next one. And that's obviously not what the sales department's looking for. So in this problem, you're given some number, and this is the iteration of your product, and you want to know what should its name be. So what's the nth positive number that doesn't have any unsatisfactory digits? And conveniently, 0 is never unsatisfactory. So in other words, there are d digits that are illegal that we can't use. We want to find the nth number that doesn't have any of those. That's the same thing as finding what n is in base 10 minus d, and then rewriting the digits of n. So if we're not allowed to use the digit 9, that means there are only 9 digits, 9 of the 10 digits that we're allowed to use. And in that case, we want to find what some number would be in base 9, and then maybe replace some of the digits later. If we're excluding 9, we don't have to replace any, but if we were excluding like 3, then we would want to replace the digit 4 with the digit 3, or the digit 3 with the digit 4, the digit 4 with 5, etc. And depending on which numbers we're replacing, it would be similar after that. So we can implement that real quick, because that's kind of a pretty common thing. So what does input look like? First we're given d, and then so we're given what each of the illegal digits are. We're going to label them all as false, or as like as legal. Sorry, that's true. Now we're going to keep track of what the nth legal digit is. So int 0, so this is like which digit we're on. I'm going to count up to 10. So if this number is illegal, then what we want to do is we want to say the nth legal number is going to be 5. Otherwise, if it is illegal, then we'll keep going until we find another or the next legal number. So now the base that we want to convert to is going to be equal to 100. And now we want to convert whatever n is into the correct case. So how do we do that? So we can do that with just the while loop. And then the thing is, when we use the while loop, we're going to read the digits from least significant to most significant. So if you're looking at a number like 117, for example, the least significant digit in that is the 7, because that only contributes to a value of 7. And the most significant is the first 1, which contributes to a value of 100. So if we were to print a number out, we want to print it from most significant to least significant. But when we do this conversion, it's a lot easier if we do it from least significant to most significant. So we're going to make an array list. Of our answers, and then we're going to store this our answers as we have them, and then at the end we'll print them out in a backwards order. So while 10 0, the digit is going to be in my case, and then we can take up this digit. And we can add n to our answer. Now we have to, well, actually, we don't want to add n, we want to add the digit. So now we have our answer constructed. Now we just need to print it out. And print a new line and be clean. Alright, so basically just to go over what we're doing, we are marking all the digits they tell us that are legal as legal. We're finding all of the legal digits. Once we have them, we just need to convert n into the correct case. We do that, and then we replace the digit with whatever digit it should be, and print out the answer. We can check that code, make sure it works. 0, 1. Ah, not quite. So should be 10, right? Surely. So that means we are printing things in the wrong order. We don't want to add n, we want to add digit. So so we want to add the digit converted, not n converted. Basically, that would work, but I guess it happens when you have some input, everything less than 10. In the second sample, we get 23, which is the intended, or the correct answer. So those numbers, just for clarification, would be like 2, 3, 4, 5, 6, 7, skip 8 because it's legal, 9, and then we'd have to skip 10, 11, 12, etc. because those all start with a 1. And then we'd have 20, 22, and 23. Skipping 1 again because it's legal. So that is how you do Windows. The runtime for this solution is order number of digits in the answer. So that would be like number 18, basically. If the input has 18 digits, which is equal to, or really it's order number of digits in the correct case. So if you have an 18-digit number in base 10, that could be almost 64 digits, closer to like 60 digits, I think. In base 2, if there are only 2 digits you were allowed to use, which would be the smallest. So it's like order 60 for this part. That's definitely fast enough. That'll run really fast. If you try and count up individually all of the numbers that are actually legal, that's going to be way too slow. That'll be order 10 to the 18, which is never going to finish in any reasonable amount of time. So yeah, this was kind of like the only way to do the problem, but also a pretty intuitive, like straightforward way of doing the problem. And base conversion is definitely something that you got to know for the AP exam. This comes up all the time. So this is a pretty helpful problem with that, I think. So yeah, hopefully you guys enjoyed, and then I'll see you in the next video.